Good, sir. For MMF.
Okay, in one problem, how can we find length? Those things you are asking for.
So what should be the length for calculating the MMF in a circuit?
Mean length.
If it is a toroid, then the mean circumference area you should take. Like if you have a toroid of inner radius r1, outer radius r2, then you should take length as 2 pi r1 plus r2 divided by 2. So average circumference you should take. That is the length. Similarly, whenever you have a square, then you should take the means circumference there also. I mean the perimeter, not circumference. So if it is having, say, it will be clear if I take problem. I'll show again. Let me share the screen.
Okay, sir.
Okay. So last class, someone of you told that the value of magnetizing current for that particular problem came to be 4 ampere. Isn't it something like 4?
Yes, sir.
Uh,
I was.
that is correct. Actually, what I told 3 there, I made a mistake. I took a wrong cross section area, so it has to be 4. Whatever solution was there in the slide, na. Anyway, I have not shared the slide, so I'll do one thing. I'll copy the correct solution there in the slide and share with you. Okay. So let us now take a new problem. So we'll take the problem where we have more than one coil, 2 coils precisely.
Sir, can you use quad coil?
Can we
Use quad coil?
quad? That means 4.
Yes, sir.
You can
In
use.
a big square under 4 different type of
In a
square
square, in the
coil.
all 4 limb, you can put coil, no issue. So total MMF will be addition of that 4 coil. Okay. So this is the problem which we were taken up in last class, I think, and their solution came as 4.0644 ampere. Okay, so around 4. This I'll share now, and let us do the new problem where we'll use 2 coil. So let me draw the circuit first. So it is a circuit where it given that you have this is your mean circumference. You are asking na, about how we can take the length. So mean length you should take, and here directly it is given. So this is given to be 250 mm, 250 mm. Okay, and same here also. It is also 250 mm. And this is also 250. So you get your mean length. How come? This is, if we have to take only for this part, it is 250, 250, 250, because this is also 250, right? And what are given? We have 2 coils. This is your coil I1, coil 1 carrying magnetizing current I1, and number of turn N1. This is coil 2. This is coil 2 carrying current I2, number of turn N2. N2 is provided to be equal to 250. Oh, sorry, N2 is provided as 2000, and N1 equal to 5000. So number of coil is given, air gap is given, mu r is given. Mu r of the material is 10,000. That is given. Okay. And what else is given? Air gap length is given, which is equal to 0.1 mm. So what is told now? It is told that the flux in the branch, say this is the branch A. This limb is known as A, this is B, this is C. And it is told that for phi A, that means through limb we have a flux which is equal to 4 milliweber, and phi B, that means through the limb B, flux is equal to again 4 milliweber, through C, phi C equal to 0. Okay, so this is given. Then what we have to find out? We have to find out what is your I1 and I2 for it. To satisfy it, what should be the value of I1 and I2? That is our question that we have to solve, right? So you can see these two are in parallel path. So what we can write? We can write first equation, which is equal to phi B into SB, that means reluctance in the path B, is equal to, or SB we can write at SB plus SG, because SG is your air gap, that is equal to your phi C into SC, isn't it? That we can write. This is the first equation, because this is a parallel path, so MMF at these 2 points will be same, whatever be the path of this magnetic circuit. And what else for this one, for
Sir,
the
S means reluctance, right?
S is reluctance, yes.
Okay.
Reluctance of magnetic circuit. Okay. So now to have a
What is SG?
SG is the air gap reluctance for this air gap, and SB is for the
Okay.
limb. So what will be our SB? SB is equal to, what is our length? Mean length is 250 mm, right? So we can write 250 into 10 to the power minus 3 divided by cross section area is, I forgot to mention, this is given uniform, and that is equal to 25 mm square. This is your cross section area for all the three limb throughout this same cross section area. So cross section area A is equal to 25 mm square.
Sir, one thing I couldn't understand. Sir, how phi C is 0 when there is current I2 in the third one?
Yes, this is because whenever say you have a purely resistive circuit, right? I'll just draw it here with a resistive circuit. We have V1. This is your R1, R2, RG. And this is your R3. And that is your voltage. Here, this is V2. So now, what is the drop here? If the current will be flowing through it here, the drop may be at this node. Maybe this is V if we take up for the time being. If this is V, then how come the current through this path will become 0 when this is equal to having same potential, isn't it? So if this V and this 2, this V is what? The drop across this. If the branch current is I through this branch, if the branch current is I, then what is that? It is equal to I into R2 plus RG. So R2 plus RG should be equal to what? R2 plus RG should be equal to the voltage across this. So net this voltage we have to use here. So what is that? It is V2 minus, if this branch current is I3, then I3 into R3. So then what to do? If we put the entire thing, if you want this I3 to be 0, your entire V should be equal to your V2, isn't it? Then only no current will be flowing through this path. Correct or not? Here you have a potential V. So this potential is equal to MMF here. MMF for this path. If you relate this, this is what? This is 5V into SB plus SG. So that should be equal to your current should be opposing this thing, so that no flux will be flowing through this path. Or if a current has to, if a flux line is going through this, whatever mmf will be prepared in this, it will be developed in this path, it is same as this. If phi c would have some value, then that phi c should be equal to, that mmf should be equal to the same mmf of this. So that should be nullified by this coil. So that is why we'll take I2 into N2 equal to this mmf, and that should nullify the effect of this flux mmf. So it will have a opposite direction, the direction of the direction of the current in such a way that it should oppose the mmf produced in this path. So if it is in this way and this way, so current will be in such a way that it will be going up. If it is downward, then it should go as a up. So that is why we can write phi c into sc is equal to your n2 into I2. This is another equation. And what is your n1? This is your mmf2 for the coil 2. And what is your n1 I2, which is your mmf1? mmf1 will be equal to phi b into sb plus sg plus phi a into sa. So your phi a is given, your sb is equal to given, phi b equal to given, sb, sg and ac you have to calculate and substitute here. Okay, so let us do that. Then what is our sb? Is it clear now why it is happening? How phi 3 can be
Yes, sir.
0? Okay, fine, thank you. Then we can now calculate what is our SB. SB is equal to what? SB, for that the length is equal to 250, because 0.1 we can ignore, it is 249.9, so we can ignore that. 250 into 10 to the power minus 3 meter by this is a magnetic material, so mu 0 mu r, again we'll use that mu r later at the end. So mu 0 mu r into 25 into 10 to the power minus 4. Okay, so that will give you this. This is SB, and what is your SG? SG is equal to 0.1 into 10 to the power minus 3 divided by mu 0 mu r 25 into 10 to the power minus 4. So if you solve this, it is supposed to be, I have solved a priori, so just cross check. It should come as 56 by mu 0 mu r ampere turn. So that is your SB. Oh, sorry. No, actually, then if we solve, if you substitute this value of SB and SG here, and if you put the value of phi, let us write it. So phi B into SB plus SG comes out to be 4 milliweber. So 4 into 10 to the power minus 3 into 250 by this means it is 100. 100 divided by mu 0 mu r, isn't it? Because it is 10 to the power minus 2, and then 25 will cancel out, so 100 by mu 0 mu r, and then here it will be it will be something as 1 by 25 into mu r will be 1 here. So what we can do, we can multiply either mu r above and below, or we can put as 0.1 to the power minus 3. So it is mu r, that means it is 10 to the power 5 divided by, sorry, 10 to the power 4 divided by 25 into mu 0 mu r. So it is 40, isn't it? So it will come as 140. Ultimately, if you solve this, it will turn out to be 56 divided by mu 0 mu r, and that will be the requirement for the mmf2, which is your n2 I2. So this is phi c SC.
Sir, MMF1 is N1I1 na? In the middle which you have written, MMF1 is equals to N1I2. It should be I1.
I1, sorry. N1 I1 equal to MMF. That is equal to sum of this. So phi C SC will be equal to 56 by mu 0 mu r, and that then if you put their value, if you put the same value of your mu r and mu 0, mu 0 is 4 pi into 10 to the power minus 7. So it will come as 56 divided by 4 pi into 10 to the power minus 3, and that is equal to 2000 into I2. So from here, if you solve I2, it will come as 2.228 ampere. Okay, so that is for the coil 2. And now for the coil 1, what we have to solve, this phi b into SB plus SG is equal to actually phi C SC, same as that. So that we have already calculated, which is 56 by mu 0 mu 1. Now for the other part, like this, and this, what will be your SA? SA will be 250 plus 250 plus 250, it is 750 into 10 to the power minus 3 divided by mu 0 mu r into 25 into 10 to the power minus 4. So it is turns out to be how much? It is 300, isn't
Sir,
it?
wait, sir, millimeter square. So it should be 10 to the power minus 6 here.
Yes,
SC.
sir, at the -6.
Okay, yeah, right. So here also it will be 10 to the power minus 6. Accordingly, we have to solve. Anyway, I don't know. I have written what I can see in the paper. I have written 10 to the power minus 6. It's my mistake. I hope the calculations are correct. So just you cross check if the method is like
Sir,
this.
I have a doubt.
Yes, continue.
Sir, in SB, why are we not taking the mean length as 250 minus 0.1?
Because if you take that 250 minus 0.1, it will turn out to be 249.9 10 to the power minus 3. So if you calculate the difference between these two, 250 or 249.9, it will be negligibly small, that difference. So that's why for the ease of calculation, we are doing it. But that you can write, or you can write like this and you can solve it. No problem.
Okay, sir.
Okay. Ideally, we should write this 249.9 and then we do the calculation, whatever be the minor difference. But if you write this statement that it is negligible, small difference, then you can continue with 250. No issue.
Yeah,
So
okay, sir.
so it is now 10 to the power minus 3. So it is 30 into 10 to the power 3 divided by mu 0 mu r. So now when you multiply it 4 milliweber, it will come as 80 equal to, I mean, your phi A SA will be equal to 120 into mu 0 mu r. So now what is the total N1 and I1? It is 120 plus 56. So that means 176 mu 0 mu r, and that is equal to 5000 into I1. So mu r, you know, it is 10 to the power 4. So 176 divided by 4 pi into 10 to the power minus 3 divided by 5000 will give you your I1. So that turns out to be 2.8 ampere approximately. Okay. So this is how you can solve a problem when you have the together you have two coils. Okay. So let us now take a problem where the mu r is not specified, but we are given a table. So in that case, how can you solve it? Then your solution approach will be a bit different. Okay. So how we can solve it? Let me show you. So you have a magnetic circuit like this. Here you have a magnetizing coil carrying current I. Air gap is given, these lengths are given as this is 5. There is a thickness. Okay, so there is a thickness like this, and this thickness is same uniform throughout, and that thickness is equal to 3.75 centimeter. And this is equal to 2 centimeter. This is also 2 centimeter. Air gap length is 0.5 millimeter. Air gap for all three air gap, we can see here are three air gap, 1, 2, 3, 1, 2, 3. That all three air gap length is equal to 0.5 mm, not centimeter, 0.5 mm. Mind it. This is 5 that is given. The mean circumference, mean length here, it is given as 10. And this is 20. This is 20. Okay, so if these things are given and then air gap here, air gap flux phi a, that is equal to given. This is equal to 1.7 milliweber. Then in that case, how can you solve the problem when you are given a table like this? There is a table which is also given, H and B table. So H is equal to 440, for that B is equal to 0.8, then 440, 0.9, 500, it is 1, B is Tesla, and H is in 80 per m. Okay, that is the unit. 1 point. This is in Tesla. This is 80 per m. So that table you are given. So based on that, you have to solve it. So what is the cross section area of the central limb? First of all, what is given here? It is phi a in the central limb, that is given. Phi a equal to 1.7 milliweber, and we can see this entire circuit is symmetric about the central limb, so it will have the equal reluctance, and this phi a will be divided as phi a by 2 here and phi a by 2 here. Equally it will be divided, the flux. So what first we have to find out what is the cross section area of the central limb. That is equal to,
So what is 3.75 centimeters?
3.75 centimeter is the thickness of this. There are it is actually stacked. This is a two-dimensional thing. You stack one upon the other, and then you get a thickness like this. Okay, this thickness.
Okay, sir.
So here also it is 3.75. As I told, it is a uniform thing. So this is 5. If you take the top view of it, this is 5. This is 3.7. So 5 into 3.7 centimeter square, and that turns out to be 18.75 10 to the power minus 4 meter square. So then what is your BA at the central limb? It is equal to phi a divided by this cross section area, say this is A. So phi a by A, which is equal to 8.75 into 10 to the power minus 4 divided by, sorry, it's the other way around. Phi a, it is in the denominator, phi a is equal to what? It is 1.7 into 10 to the power minus 3. So if you solve this, it is 17 by 18.75. So that came as 9067 Tesla. So if BA is given, then what is your H? Because to find out the MMF, we need to find out your I current. What is our I current? Now to find out the MMF, we need either phi into S, or we need H into L. So here what we'll do, we'll solve using H into L. So BA is given, we need to find out HA, and LA is known to us. LA is this length. This is 10. So that is the thing actually. So HA, if we have to find out from this table, we have to solve using the method of interpolation. So for 0.9, H is given as 440 ampere turn per meter, right? So then we should start like this: 440, that is for 0.9, then 440 minus 400 divided by 0.9 minus 0.8 into 0.9067. Oh, I wrote the wrong way actually. It should be the other thing. So here it is between 9
Sir,
and 1.
Sir, what is 1 3 here in the limb, in the left and right limb? What is 1 3 at the bottom of the limb?
1 is the air gap 1, 3 is the air gap 3, 2 is the air gap 2.
Okay, so all the air gaps, the thickness is same.
Same, yes. It is 0.5 mm for all. Okay, all air gap. That is why it is symmetric. Otherwise, it is not symmetric. If the air gap flux phi a here at, I mean phi 2 here, it is given 1.7 milliweber. Then because 1 and 3 are having same air gap and same length, same material, that is why reluctance is same. So your flux will be uniformly distributed. So it is phi a by 2 this side, phi a by 2 in the other link. Now what we are doing here, we are trying to find out HA for the BA is equal to 0.9. We are given for 0.9 it is 440, for 1 it is 500. Then we should write it as 440 by the method of interpolation. 500 minus 440 divided by 1 minus 0.9 into 0.9067 minus 0.9. So it is, that is the method of interpolation. Okay, so we are taking the slope, and accordingly whatever delta change from 0.9 that we have calculated, then that into slope will give you the total thing. So it is 600 into 0.067, and this is calculated as 444.02 ampere turn per meter. So once you can find out H equal to 444.80 per meter, then you can find out what is required 80 for the central limb. So 80 for the central limb, ampere turn or MMF required for central limb, that is equal to 444.02 into what? It is 10. So 10 into 10 to the power minus 2, that is for the magnetic material part, plus what? 0.9067 divided by mu 0, that is for the air gap. So that into 0.5 into 10 to the power minus 3. This is the air gap length, right? And mu 0 is 4 pi into 10 to the power minus 7. So this, the whole thing come as 360.7680. So total 80 is 405.1680. That is the 80 required for the central limb. So for this one, now what is left? Left is this. This is 10. This is again 10. This is again 10, and there is the air gap. Okay, so 10 plus 10 plus 10, it is 6. It is 30. 30 centimeter is the length of the magnetic material, and rest is for air gap. So that 80 now we have to find out. So for that, what is the flux here? Flux is for this path, it is phi a by 2, which is 1.7 by 2 into 10 to the power minus 3 Weber. And what is your cross section area? Here the cross section area is different. This is phi and this is 2. Mind it, it is given as 2. Okay, so 2 into 3.75 is your cross section area. So A is equal to 2 into 3.75 for this other limb, that centimeter square, which is supposed to be 7.5 into 10 to the power minus 4 meter square. So what is your B in that case? B is equal to this is 7.7 1.7 by 2 10 to the power minus 3 divided by 7.5 to 10 to the power minus 4, and that came as 1.133 T Tesla. So if you find this B, then again from the table you can find out what is your H. So that H is equal to, it is more than 1.1. So we'll write 600 first. Then it is 800 minus 600 divided by 1.2 minus 1.1, then into 0.033. So that delta change. So that's supposed to be 606.6 ampere turn by meter. So this is the slope of this line. If you just draw the point like that, so difference in the H divided by difference in the B into what is the delta change from 1.1 to 1.133. So that I have done, and from that I got H is equal to 606.6. Now this is the time to find out the AT for the other
Sir, your
limb.
screen is lagging, sir. Only I have been shown till ampere turn required for central limb, or rest what you are explaining is not there. Oh, now it is coming slowly.
Yes, sir, very much lag, sir.
Actually, we have lodged complaint to the server room. They are saying that BSNL server is very poor for in any. There are a lot of port na with which we are connecting. So in any IP, it is not connecting actually. I'm helpless. I'll share this screen. So
In this
that
question, actually, what we are actually finding, sir, that only.
what is your I? What is your magnetizing current?
Acha.
For this, mostly you will get the problems like that. If you have a coil, how much current you have to drive through that coil so that you get this much of flux. Air gap flux 2 is given, phi a in the central limb, it is 1.7 milliweber. So for that, how much current you should drive in the central limb coil. So what I am trying to find out, I am trying to find out the AT here in this path and AT here for the other path, and this will be the same. Like what is the voltage required to drive a current of that similar kind of thing. So that is why part by part I am taking the ampere turn and then I'm solving for it. So ampere turn required for the central limb is this to drive this current. Sorry, to drive this much of flux. So that I have calculated from the table. This is for the central limb. Now I am calculating ampere turn required for the side limb, and that will be same,
Sir, how
right?
you calculate the H?
Sir, why are you
That part
adding it?
600 plus.
One by one, please tell one by one. How are you calculating H?
No, sir. How are you
600
adding?
plus 600 plus 800 minus 600 by 8.
That is
1.82
actually this is the point, na. Say if I draw in graph, this is for 1.1, it is 600. This is 600. This is 1.1, and then 1.2, it is 800. This is the line joining this. So what will happen in 1.133? It is somewhere close to 1. So what is that value? How can you find it out? This is 600 plus this slope into this delta change. So that is what I am doing. 600 plus, what is the slope for this line? It is 800 minus 600 divided by 1.2 minus 1.1. And then for the small delta change, that I am multiplying. Got it? Like
Okay,
here,
sir.
same.
Got it.
This is the interpolation actually. This is how we interpolate and vary it.
And sir, in area required for central limb, why are you adding the mu naught that thing? Like we have got from HA, so then why are you adding extra 0.9067 by mu naught plus into 0.
Here, which part? This part.
Sir, on the left hand side, the ampere turn required for the central limb, why are you adding this thing 0.9?
Okay.
Yeah.
Okay. Here, this one is your H. What is your H in the magnetic material? That you get from here, right? From this table. This is for the magnetic material table, pH curve data. Agree? This one,
Yes,
this
sir.
table. But whenever the what will be the flux density what will be the intensity when it will go through the air? Then you don't have the table now. Whenever you have table, then from there you can find out your H, isn't it? You know B, so for that you are finding out your H. B is constant through the air gap also because the cross section area is same, flux is same. Then but H will change because the relative permeability is different for the air. So for that you don't need this graph, right? We need this graph because we don't have the value of mu r, so we cannot divide it by mu r. But here we can divide because we know what is mu 0 for the air. So we don't need any table for it. Otherwise, if instead of air, if it is a different magnetic material, no, say it is material 1 and then for the gap there is material 2, then will be provided another set of table through which we have to find out your H. H won't be same for the different material, but B will be same. Got it? Am I clear now?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
That is why this additional part has to be solved. Now,
But one thing, the H that we know, that is the external magnetic field that has been applied, and B is
it is
actually
intensity, magnetic field
the
intensity.
intensity, and B is actually the intensity which is actually going inside the material. So, sir, why we are mean focused on H? That is the external factor, not the internal factor for the calculations.
H we are for this we are calculating H because we need to find out our H into L. Either we have to calculate H into L, which is equal to your MMF, or what else we have to find out? Phi into S, reluctance. Agree? Either we have to find this or we have to find this, isn't it? So whenever we have to find your S, then we need the value of mu r, which we cannot find from here. That is why we are taking the other approach, which is the
Okay.
Ampere Circuit Law. Like the closed contour of H into dl is equal to your Ni, which is equal to MMF, magnetomotive force. So instead of solving in this way, because we do not have the value of mu r and we cannot calculate your S, we are solving in the other way. Okay. Got it?
Yes, sir. Yes, sir.
Okay, so now for the side limb, let me calculate the AT, what is required AT, which is be 10 plus 10 plus 10, so 30 into 10 to the power minus 3, minus 2, not minus 3, it is centimeter, into 606.6, that is your AT per mm for the side limb. So that into again 1.133 divided by mu 0. This is again that air gap we have to consider 0.5 into 10 to the power minus 3. This air gap we have to consider. So that, and this has come as 181.98 plus 450.8 and supposed to be 632.78 AT. So now for the total, what is the MMF required? MMF for the central limb 405.16 and 632.78 for the side limb. So as a whole, total AT is equal to equal to 1038. So once you know the total AT, then if you divide by the number of turn, which is equal to 500, I forgot to mention. So many data is given, actually I'm missing out while copying. So 1038 is the total ampere turn required, and coil number of coil is 500. So if you divide this with 500, you get your I, which is equal to 2.076 ampere. Okay. So there are again a few more problem. I don't know what you want. Shall I explain in the next class, or directly I'll share the solution? You want, if you want me to explain, I can explain in the next class again 2 more problem, or I'll just solve and share with you. Which one you prefer?
Sir, explain,
Sir,
sir.
share the solution.
Yes, sir.
Sir, share the
Explain.
solution
Explain,
and
sir.
next class explain the
Okay,
solution.
solution to anyway I'll share. No issue.
Once we will try, sir, then you explain in next class, sir.
Yes, sir. First give the
You
solution, then
state the solution and we will try. If we have any
We cannot
problem,
understand. Okay, okay, that will be better then.
Yes, sir.
Because so many
if
problems
we
are
have any
there, it
problem,
will
we
take a
explain.
lot of class. That will be better. Okay. Okay then. Okay, we close it for today, and I am sharing these slides with you so that you can refer. So if there is no other question, I'll close for today.